Hey, how you doing? This is Coach Hyde coming at you with some biotech stuff. Grab me a marker here. We want to use orange looks good. So we're looking at plasmid mapping and kind of the basics, the introduction to plasmid mapping. First off, let's look at this right here. Okay, so this is the name of our plasmid. We got a couple sections to this. We got a P. P just stands for plasmid. We got some alphabetical letters here. This is going to be the institution that it came from. It could be UGA, University of Georgia, UC, University of California. It could be some, whatever, some kind of institution. And then here, this could just be the ID at the institution of which plasmid it was made. Next thing up, we have this here. Okay, this is just going to be our size. BP stands for base pairs. So if we're just thinking about how many base pairs we have in a line, so this would be like 4 base pairs. That would be a strand that's 4 base pairs in length. This whole plasmid would be like 8,000 of these base pairs around, right? So there's that. That's kind of our start. Now let's look at it. We have a plasmid. Plasmid is circular. So we have the beginning here. This is our origin. It's labeled ORI. So this is our, both 0. It's also the 8,000th base pair. Okay, because it's a circle. It's the start of the circle. It's the end of the circle at the same time. So it's kind of both of those things at once. This is where replication starts. Origin is where replication starts. It does not have to be top center like this. It could be the origin, it can be here, it could be here. I tend to kind of start with it up the top middle just for consistency's sake. So let's look at what else we got. We got some other lines coming through here. Okay, these are going to represent restriction enzymes. And restriction enzymes are going to cut our DNA. And they're going to cut at restriction sites. So this is the restriction enzyme name, the identification, and the line where it goes through the circle, that is going to be the location of the restriction site. That's where that enzyme is going to cut. We see this blue square here. This is our MCS. This is our multiple cloning site. This is going to be our go-to area for genetic engineers or anybody who's studying these plasmids, where we're going to know their specific enzymes engineered to be there, so we have a place where we can get this plasmid open. We can insert genes, we can remove genes, whatever it is our goal is at that point. So this is going to be typically loaded with a lot of restriction sites for restriction enzymes. This is not an arrow. Okay, the arrows are going to represent genes. This is a location on the plasmid. It's not a gene. Multiple cloning site, or it's a site. It's not a gene. So we have a arrow pointing this way, which would be, if you think about it like a clock, it's kind of going backwards around the clock. This is counterclockwise. We have a gene here that's going normally around the clock. So this is a clockwise direction. You see they're kind of pointing in opposite directions there. So this lets us know, if you remember what we just had up here, we got the DNA has the 2 strands. Okay, so one of these genes is going to be on the top strand, one of these is going to be on the bottom strand. It's very specific, as is it 3 to 5, 5 to 3, whatever the transcription is being read, or the transcription reading is going to either be on that forward strand or that reverse strand. So if it's going clockwise, normally around the clock, these are both pointing in the same direction. I meant to make one of them pointing in the opposite direction, which I did not do, so let me just edit this. Okay, now one of them is pointing clockwise and the other one is pointing counterclockwise. This one that is pointing counterclockwise, all right, this is going to be on the the forward strand. So the counterclockwise is going to be on our forward strand, and then the clockwise, the one that's going around the clock normally, this is going to be on our reverse strand. I always get those backwards because I want the one to that's going clockwise. I want that one normal to go forward. So I get tongue tied on those a lot. But now next thing is, let's kind of talk about the distance of the fragments. Or before that, so if I wanted to cut this gene out, I wanted to remove this gene, I wanted to pick 2 restriction sites as close as possible. So this SMAI and Hindi, those would be good. So if I was to cut here, I would really only have that gene, right? But if I was to not cut it Hindi, let's say I cut here and here, now I would end up with a section of DNA that doesn't code for my protein. It might not have no effect, it might be fine, or it might bring something to it that we don't want to. Whereas up here, if I was to choose this as one of my enzymes, and I was trying to cut out the red RFP, I just use red fluorescent protein, green fluorescent protein as my genes. If I had an enzyme that cut through the gene, now that gene, if I did get it out, is cut in half, so it's not going to work. So if I was picking the enzymes out that I wanted to use to get out of a gene, I want to get as close to that gene as I can without cutting or splicing into it. All right, so kind of next real quick. So if this is 8,000, let's talk about locations around it. So 8,000, half of the plasmid away, right, from here down to the halfway point, right? This is halfway of the plasmid. It's just going to be half of the total. So have 8,000 total base pairs. Half of that is 4,000. So this is base pair number 4,000. Okay. So if I was to go a quarter of the way, right, 1/4 of 8,000 is 2,000. So that's base pair number 2,000. So it's just kind of like 2, 4. This one would be 6,000. 8. So, and you just kind of keep breaking it down from there, okay? So, for example, well, what's halfway between here? What is this base pair? Okay, so that's between 0 and 2,000. So this is 1,000. So it's kind of like 1,000, 2,000, 3,000, 4, 5, 6, 7. Right, you can break it down more. Base pair 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500. Right, so you just kind of, to figure out what base pair location it is, you just look at it kind of like a pie chart, as if you were going to set one of those up. Now, real quick, let's say that you were given information, you were asked to draw a plasmid map. Okay, let's say that you're given plasmid PSAT01. We'll say that this plasmid is 1,000 base pairs in length. It's going to be cut with 3 restriction enzymes: EcoR1, EcoR2, EcoR3. All right, just keeping it simple. They're going to be cut at, we'll say, 500, 650, 250. Okay, and maybe gives you the gene for insulin. This one's going to be at, what would I say, 125, base pair 125 to 250. And this is going to occur 3 to 5 on the reverse strand. And you were told multiple cloning site is going to be do that much. 25 to 250. We'll say that all right, 650 to 750 pp. All right, so first things first, let's draw us a circle and let's get that origin going. Again, it's not always there. I like to start with the origin, top center. It's just, I don't know, have it. Let's go ahead and name it. So we'll use this information to name it. Name's in the middle, PSAT01. It is 1,000 base pairs. So we named it. That part's done. Let's go ahead and map our enzymes. So we'll do this section next. So if our plasmid is 1,000, so this is both 0 and 1,000 up here, which means halfway around, half of that 1,000 is 500. Okay? So that's our 500 mark, which is where we would label this one, right? Cuts at the 500 BP mark. This one here cuts at 650. So we know if this is 500, we know we're over here on this side. Okay, so what is between 500 and 1,000? So we know like right here would be 750. Right, so we're not quite there. Right, between these two would be roughly like 625, right in the middle. So 650 is going to be a little bit past that midway point. So we'll say this is eco R2. Right. And then lastly, 250. We know this is 1/4 of our between 1,000 and 500. This is the 250 mark. So this is our other restriction enzyme. So we've got them all mapped. We mapped our restriction enzymes now. Next, let's say we have the gene for insulin, right, from 125 to 250. Between 0 and 250 is 125. So it's going to start kind of in the middle, and it's going to go all the way to this 250 mark, right? It is 3 to 5 on the reverse strand. Now, our reverse strand is going to be a clockwise arrow. So the arrow would go clockwise like a normal around the clock situation. So we're going to kind of go here. So here is our gene, right, for insulin. I reckon that marker's about done, huh? I missed that terribly. Anyway, next up, let's say multiple cloning site from 650 to 750. So we know this cut cell is here is at 650. We're going to work that to 750. This is not an arrow. This is a square because this is a cloning site. This is not a gene. So we have accomplished our things. We mapped out where our restriction enzymes, our restriction sites are. We did an insulin gene. We ran it in the reverse strand, which is a clockwise arrow, and then we mapped our multiple cloning sites. So, hope this helps with your plasmid mapping endeavors. That's it. See y'all next time.